Here I want to take a look at topic 64, just one of the concepts for stretches and compressions. Here on the left we have an example of vertical stretches and compressions, and on the right we have horizontal stretches and compressions. But what I really want to focus on is this K value, whether it's for vertical or horizontal. For vertical, which you're going to see far more frequently, all right, we spend a lot more time talking about vertical stretches and compressions, so be a little bit more familiar with the vertical side than the horizontal side. But what we're looking at is, we want to focus again on this down here. It's a stretch when the K value is greater than 1, and it's going to be a compression when K is between 0 and 1. This is absolutely the key for this topic. K being greater than 1 is going to cause a stretch. Now, if you look at the graph we have here, the original, the black function here, is our original function. All right, for this specific example, we'll just call that f of x. Now, when k is greater than 1, you're going to see that the graph is pulled in a vertical direction. All right, it's going to be stretched up and down, and it's going to be pulled away from the x-axis. It's going to be stretched vertically. And then if the k value is between 0 and 1, so something like 1/2 or 0.2, 0.8, what will happen is this blue graph. And if you notice, kind of my turning points are pushed or compressed towards the x-axis. And we're treating this as the x-axis right here. So it's being pushed towards that, and that's why there's being a vertical compression. So think of it as pressure from the top and the bottom, pushing it from vertically, compressing it towards the x-axis. So one more time, a compression would be if it's between 0 and 1, we're pushing our graph kind of towards the x-axis, and a stretch, a vertical stretch, keyword here being vertical, a vertical stretch is when we're pulling our turning points, are kind of getting pulled away from our x-axis. Now, in terms of a horizontal stretch and compression, we kind of talk about the same thing, but they're the opposite, they're backwards. A horizontal stretch, so sorry about that, I'm looking over here now. A horizontal stretch is when k is between 0 and 1. And what will happen there is the graph is going to be pulled wider, or you can think of it as wider from the left and right side. And we can see that in this orange graph. It's going, our turning points are getting pushed or pulled to the left and pulled to the right. Not the easiest to see. Horizontal stretches are generally, they're less common, or we use them less frequently in this course, but they're a little bit more of a pain to deal with. And they are backwards. So the compression would actually be if k was greater than 1. And you can see that it's kind of being flattened. It's being pressed in towards that y-axis. What you want to remember is that in terms of vertical and horizontal stretches, vertical we always think y-axis, up and down. So a vertical stretch or vertical compression moves the graph in the directions up and down, but it actually looks like it's in relation to the x-axis. So it's either being pulled away from the x-axis or being pressed or compressed towards the x-axis. So hopefully that clears a little bit of confusion up. The vertical stretches and compressions we definitely do a lot more work with, so you might want to be a little more familiar with them. And just remember this down here, that k value, and unfortunately we refer to a k value here, but a lot of times later it's going to be a value of a. The book just likes to confuse people, I mean, quite honestly, but that will be an a value when we get to specific forms. Good luck with it.